This is your class number 4.7 of module number 4. Students, in this class, we are going to solve one problem on this flat face type of a follower. Only I'll change the type of follower and the remaining conditions will be almost similar. And let's get started with today's problem. So problem number 5. First, I'll read all these given statements. Draw the profile of a cam to impart the following motion to a flat-faced follower. So clearly it is given, it is mentioned in the problem, the type of follower is a flat-faced follower. So first you need to confirm this one, whether it is a knife edge or a roller type or a flat-faced. And it is confirmed the type of follower given is a flat-faced follower. And they are given the 4 angles. Also they are mentioned the stroke length of the follower. First condition, follower to move outward through a distance of 60 mm. It means the maximum distance that is traveled by the follower is 60 mm. That is, stroke length of the follower is 60. During 150 degree of cam rotation, it means the follower is moving outward. It means this angle is with respect to the outstroke angle. Theta O. Outstroke angle is 150 with a simple harmonic motion. Also, it is mentioned type of follower motion is a simple harmonic motion with respect to the outward stroke. And in the second condition, it is mentioned that the follower to return to its initial position during next 150. It means immediately after covering this outstroke or the immediately moving towards upward direction, it will not take rest. It means there is no dwell at all. Immediately the follower will come down. It will return back to its original position for the next 150. It means this is theta r. Follower to return to its initial position during next 150. Next means immediately after this. It means there is no dwell between this outstroke and the return stroke. It means theta d1 is 0. For cam rotation with uniform acceleration and retardation motion. It means the return stroke is with a uniform acceleration and retardation motion. And after this, the third condition, follower to dwell for the remaining 60 degree of cam rotation. So after covering a total 300, for the next 60, the follower will be under rest. Okay, it means the follower will move outward for 150 degree of cam rotation, and immediately it will come down. It will return back for the next 150, and for the next 60 degree of cam rotation, there will not be any movement of the follower. It means it remains in the same position. It means in the downward position for the next 60 degree. It means the displacement of the follower for the next 60 is 0. That's why it is called as that well. It means theta d2 is 60 degree. And it is given the line of stroke of the follower passes through the axis of the cam rotation. It means the type of follower is radial, not the offset follower. And one more is the flat face of the follower is right angle to the axis of the reciprocating follower. Okay, I'll show this in the picture. And one more parameter is given as a base circle diameter of the cam is 50 mm. Just observe it is a diameter, not the radius. Base circle diameter is of the cam is 50 mm. It means the radius will be 25. Yeah, do not confuse with this one. Sometimes you'll take directly this as a radius and you'll draw a circle with a radius of 50 mm. That will be a mistake. Okay, and after this, I'll note down the given things. As it is given the stroke length of the follower is a 60 mm. In the first condition, it is given the follower is moving towards in outward direction to 60. S is given. Diameter of the base circle is given as 50 mm. I'll convert into radius because I want the base circle radius, not the diameter. So it will become 25 mm or 2.5 centimeter. That is capital R. So this is important and this is important. And so these are the 4 angles what I have discussed so far. That is a theta naught, the outstroke angle 150 with simple harmonic motion. Means for the first 150 degree of cam rotation, the follower will move in upward direction. After that, there is no dwell because it is given in the problem immediately for the next 150, the follower will come down. It means the follower will not take rest at the top position. It means it will come down for the next 150. That is nothing but a theta r. It is a return stroke angle with a uniform acceleration and retardation motion. This is also very important. And after that, for the next 60, the follower remains in the downward position only. It will not rise immediately. Rise, return, rest, and again rise, return, again it will take rest. That is theta d2 is 60. And nothing is given whether the cam is rotating in a clockwise and a counterclockwise direction. You can see, so nothing is given, right? Okay. It means the follower, I can take the follower, the cam is rotating in a clockwise direction. The cam is rotating in a clockwise direction, I can assume. And after confirming all these things, and can see the type of follower is flat faced. It is not a knife edge, it is not a roller type. Okay, it is a flat face follower. And after deciding this, I'll before drawing the cam profile. And one more thing is given, the follower axis, this is, and the cam axis, they're in the same line. They're in the same line. Just wait for a second. So there is some disturbance in my native place, so please adjust for that. So I'll continue with this displacement diagram. Before drawing the cam profile, I need this displacement diagram. Yeah. So this is the first step. I need to draw this displacement diagram similar to the previous problems. So you can see for the first 150, it is a outstroke, which is with a simple harmonic motion. And for the next 150, it is a uniform acceleration in the retardation motion. And you can see there is no dwell at all. Theta d1 is 0. And for the next last 60 degree, there is one more del. It means the curve will be flat. So first, I'll use this semicircle method to draw the displacement diagram for the outstroke, because in the problem it is mentioned the outward stroke is with a simple harmonic motion. I'll use this method. I explained this in the previous class. And the return stroke is with uniform acceleration and retardation motion. And I'll use that method also for the return stroke. And I'll start with the displacement diagram. Okay. So first, I'll indicate the x-axis and y-axis. So you can see along the x-axis, I'm taking the cam rotation angle. And along y-axis, I'm taking the stroke length. Total, I want 360. I'll take the same scale. Along x-axis, I'll take 1 centimeter is equal to 20 degree. Along y-axis, I'll take 1 centimeter as a 1 centimeter stroke length. Along the x-axis, I want 360. It means 360 by 20 is 18 centimeter. Correct? And you can see the stroke length. I think it is given as a 60 mm. That is, I can take as 6 centimeter. Okay. Since I have taken the scale in centimeter, I'll indicate all the distances in the centimeter only. So this is stroke length and this is the maximum angle, that is a 360. As per scale, it will become 18 centimeters. And I'll start indicating all the angles. The first angle is 150. Just calculate 150 by 20. How much it is? 7.5 centimeter. Okay, for the 7.5 centimeter indicates it is a 150 degree. It is nothing but the outstroke angle with a simple harmonic motion. And after that, immediately there is no dwell at all. Directly, I'll indicate the return stroke angle, that is 150 degree. Okay, so you can see the dwell is 0. The first dwell angle is 0. Whether this presentation is visible, please let me know.
Yes, sir, visible.
Okay, thanks. So you can see the dwell is 0. The first dwell is 0. So immediately I will indicate the return stroke angle, which is also 150. So again 150 degree divided by 20, it will become 7.5. So which is nothing but the return stroke angle with a uniform acceleration and a retardation motion. And for the next 60 degree, so already I covered 150 plus 150, 300. For the remaining period, that is the 60. 60 by 20 is a 3 centimeter. Okay, you can take the summation, it will become 18 centimeter. Yeah. So after this, I need to divide this outstroke, which is having a distance of 7.5, into 6 equal parts. So how much it is? 7.56. It will become, I think, 1.25, right? Correct. So I'll divide this outstroke, that is the 7.5, into 6 equal parts, and each division will be 1.25, 1.25. And I'll give the naming 0, 1, 2, 3, 4, 5, 6, like this. And I'll use this semicircle method to draw the displacement diagram for this outstroke, because it is mentioned in the problem. Is it is mentioned the outstroke is with a simple harmonic motion. It means for simple harmonic motion I'll use a semicircle method. Okay, so I'll draw the semicircle here with a radius of 3 centimeter. It means the total height is 6 centimeter. I'll take the midpoint here, so it will become a 3 centimeter radius, and I'll get a semicircle like this. And I'll divide the semicircle into 6 equal parts like this, and each division will be 30 degree, because total is 180. 180 by 6, 30. I'll give the namings A, B, C, D, E, F. A, B, C, D, E, F, because this is the starting point, right? So I'll start from here, and after this I'll draw the horizontal lines towards my right direction like this. So you can start from here also, you can start from here also. So this is the first line, one more line, one more, one more. Okay, 1, 2, 3, 4, 5, 6. So these blue color lines, they are starting from these divisions A, B, C, D, E, F, and they'll intersect these vertical lines at 6 equal points, or 6 intersections. Okay, so this is the first intersection between the first horizontal and the first vertical. I can denote as 1 dash. Similarly, the intersection between the second vertical line, this one, is numbered with a 2, and the second horizontal line, which is coming from point B, so this will be 2 dash. Similarly, you'll get 6 intersection points. So I can name them as 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, and 6 dash. So I got 6 intersection points, and I'll draw the curve passing through all these points. So this is a pink colored one. So this is nothing but the displacement diagram for the outstroke, which is with simple harmonic motion. Okay, and after that I'll go with this written stroke. Again, it is having 7.5 centimeters. Again, I'll divide this into 6 equal parts. 7.5 divided by 6, it becomes again 1.25 each, like this. So each division will be 1.25 and 0.25. Since there's no dwell between the outstroke and the written stroke, I'll continue the number. I'll give the common number as a 6. Next point will be 5. 5, 4, 3, 2, 1, 0. So this will be common, because the dwell is 0. This line is common for both outstroke and the written stroke. That is, the 6th line is common for both. And what is the method for this uniform acceleration and retardation motion? Okay, so please try to recollect as I solved in the second and the third problem. So what I will do, I'll take the mid line out of these 6 lines. I'll take the middle line, that is the third line, this one, and I'll divide this into 6 equal parts. So what is the height of this third vertical line? It is 6 centimeter. 6 by 6 is 1 centimeter each. Okay, so I'll divide this middle line, or the vertical line 3, into 6 equal parts, and each division will be 1 centimeter. And since it is a written stroke, it means the curve has to come down. It means I'll draw the diagonal passing through this center. Before that, I'll give the naming, that is A, B, C, D, E, F. You can name from from the top side or from the bottom side. Okay, and since the curve has to come down, I'll draw the diagonal in a downward direction from this corner to this corner. Okay, so like this, it has to pass through this middle point. Yeah, so this is the blue color line. So this is the diagonal which is moving in a downward direction. Again, from this 6 dash, I'll join A and B, like this, like this. Again, from this point O, I'll join point E also, point D also. Okay, so this is the same method, whatever you used for a second problem or the third problem. And after that, you need to indicate the intersection points, right? You can see the line which is joining this point A. So this inclined line, it will intersect the fifth vertical line. So at this point, this will be 5 dash. Similarly, the line joining a point B, so this line will intersect line of this vertical line 4 at this point. So this will be 4 dash. This will be 3 dash, and this will be 2 dash. This will be 1 dash. So you can see the blue colored dots, which are nothing but the intersection between the inclined blue lines, and the 6 vertical lines. And after that, I'll draw the smooth curve with a free hand, and it has to pass through all these points. And before that, I can give the naming as a 5 dash, 4 dash, up to 1 dash. And I'll draw the curve. I'll continue this curve. So you can see this pink color curve which is coming down. So this is nothing but the displacement diagram for written stroke. For written stroke. And after that, for the next 60-degree, there is a dwell, means the curve has to be flat. Just continue this. I'll not show this, just continue this. Okay. So this is nothing but the displacement diagram for outstroke with a simple harmonic motion, and a return stroke with a uniform acceleration and a retardation motion. So this is simple, similar to the previous problems. After this, I'll go with the cam profile, since the type of follower is a radial type of a follower. Correct? I want the type of follower is a flat faced with a radial type. It means yeah, you can see the axis of the follower and axis of the cam is the same line, so I can call it as a radial type of a follower. And the shape of the follower is a flat face. Okay. And in that case, I'll start with the cam profile. This. So this is the flat face follower, and the width of this flat face is not given. You can take of any length. Okay. So the width of this flat face is not given. Yeah. And this is the base circle. Okay. So this is the base circle with a radius of 25 mm. So the diameter is 50. The radius will be 25. And I want this one. This is the dark black color one. This is the cam profile for the given conditions. Okay. And I'll assume that the cam will be rotating in a clockwise direction, because nothing is given about the direction of the cam. I'll assume. It means I need to indicate the angles in a counterclockwise direction. First 150, next 150, and 60. Only these three angles. Okay. I'll explain this in the next slides. Okay. So this is the cam profile, and the follower axis passes through the cam axis. Okay, first step is again same. Just take the center point as alphabet O. Draw the base circle. So with a radius of 2.5 centimeters. So in the problem it is given. The diameter is given as 50. The radius will be 25. It means it will be 2.5. Okay. Most of the students will do the mistake here itself. They'll take directly 5 centimeter. That is the diameter. Okay. Just take the radius as 2.5. And after this, just indicate the cam axis like this, and that cam axis will pass through the center of the circle, that is point O. Okay, and that cam axis here, it will intersect the base circle at this point. That will be nothing but alphabet A, and just join point O and point A. So again, similar to the knife edge follower, so again the reference will be the base circle. Just make a note. Similar to the knife edge follower, the reference circle will be base circle only. But as in case of a roller follower, the reference will be prime circle. Okay, so this method is similar to the knife edge follower. And after this, can indicate this flat face follower with some width, can take any length, because the width is not given. Can take any length, and it just indicate the entire flat face follower. Okay, you can give any height. Okay, and one more thing is, after that I'll start indicating the angles. As I said, the cam will be rotating in a clockwise. I'll indicate all the angles in counterclockwise. The first angle is AOB, that is 150. It has to be indicated on this base circle only. There is no other circles. and immediately there is a written stroke for the next 150, means a BOC will be again a 150 second angle, and the last angle is a dwell, that is for the next 60 there is a dwell, that is COA. Means I have divided this base circle into three parts. Okay, and then again follow the same steps. Just divide this outstroke angle, that is a 150 AOB, okay, into six equal parts. So what is exactly this 150 by 6? How much it is? 25.
25.
Correct. So I'll divide this base circle between point A and point B, so into six equal parts. I'll use a protractor. I'll take the reference as this OA line. I'll keep the protractor over here. I'll indicate six divisions. It means 25 each. Okay. So these are the points on the base circle, which indicates the divisions. Okay. And after that, since it is in the problem, it is given the type of follower is a radial. Means the follower axis and the cam axis are in the same line. So I'll draw the radial lines passing through the center of the circle from all these six divisions. So you can name them as 0, 1, 2, 3, 4, 5, 6. Okay. I'll draw the radial lines which will join at the center of the circle passing through 1, 2, 3, 4, 5, 6. Okay. So these are the blue color lines, which are nothing but the radial lines. And just extend them in a backward direction with some convenient distance. So you can take any length. You can take any length. After that, I'll go to the displacement diagram and I'll copy the distance from 1 to 1 dash, 2 to 2 dash, 3 to 3 dash, 4 to 4 dash, up to 6 to 6 dash with respect to the outstroke, not the return stroke. And I'll mention the distance, that is 1 to 1 dash. With the help of a compass, I'll copy those distance. If you want, I can show them. Okay, so this one is the outstroke, 1 to 1 dash, 2 to 2 dash, up to 6 to 6 dash. I'll copy these vertical distances with the help of compass one by one, and I'll transfer over this cam profile. Yeah. So after that, just draw the arcs, and these arcs will intersect these radial lines at certain points. I can indicate as 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, and 6 dash. Right. Okay. So you got 6 points. And after this, I'll continue with this written stroke. So the written stroke is also 150. I'll divide this base circle from between point B and C into 6 equal parts. This is covering an angle of 150. 150 by 6, again it is 25 each. So each division will be 25, 25, 25. So I'll give the naming. This is a common point because there is no dwell. So this is 6. This will be 5, 4, 3, 2, 1, 0. Okay. The sixth line is common. I'll not draw two separate lines because there is no dwell between the outstroke and the written stroke. It is a continuation. Again, what I will do after getting all these points, I'll draw the radial lines. So you can see the green color lines, which are nothing but radial lines, which are joining at the center of the circle. I'll extend these radial lines in a backward direction like this to some convenient distance. Again, I'll go to the written stroke. I'll go to the displacement diagram with respect to the written stroke. And I'll copy these distance from 6 to 6 dash, 5 to 5 dash, up to 1 to 1 dash with the help of compass. And I'll transfer over this cam profile with respect to the written stroke. I'll take the reference as 5. I'll draw the arc. I'll take the reference as 4. I'll draw the arc so that I'll get so these points. So this is a 6 to 6 dash will be same, 5 to 5 dash, 4 to 4 dash, 3 to 3 dash, up to 1 to 1 dash. Similar to the previous problem. There is nothing different. And after getting all these points from 1 dash to 6 dash, again from 6 dash to 1 dash, the next step is important. It is a slight change in the method. In the knife edge follower, if it is a knife edge directly, I'll join the curve passing through all these points. Correct? Since it is a flat face, what I'll do, I'll draw a line perpendicular to these radial lines. So these are the radial lines joining from 1 dash to O, 2 dash to O, 3 dash to O, up to 1 dash to O. So these are the radial lines, right? So what I'll do at this point, 1 dash, I'll draw a perpendicular line to this radial lines. Again, I'll draw the perpendicular line to this radial lines. So I'll get a total, I think, 11 to 12 perpendicular lines. So this is the first one you can see here. You can take of any length because the width of the flat face is not given. So this is the width, it is not given. So you can take any length, and this red color line, it is a perpendicular line or the normal line. This is perpendicular to this first radial line. You can see the angle. You can zoom this area. So this has to be 90. So this angle has to be 90. So you can see draw a line normal to radial line O1 dash. So this is O1 dash and this is the normal line. And similarly at 2 dash, I'll draw one more perpendicular line of any length. So you can see here, draw a line normal to radial line O2 dash. So this is O2 dash, correct? So this is a normal line. You can see this angle has to be 90. This angle has to be 90 with respect to this O2 dash. Similarly, for all those radial lines, I'll draw the perpendicular lines at 3 dash, 4 dash, 5 dash of any length. Similarly for written stroke also. Okay. Why these are perpendicular lines? Because you can see the flat face follower, you can see this one, it is perpendicular to the cam axis. So this is the cam axis or the follower axis, and the flat face is perpendicular. That's why I want these perpendicular lines with respect to all these radial lines. So this is the only change with respect to this flat faced follower. And after this, the last thing is again same. Just draw a curve from the starting point O in such a way that it has to be tangent to all these perpendicular lines, all these red color lines. You can call it as a normal lines also. So the curve has to be perpendicular or a tangent. Sorry, the curve has to be tangent to all these perpendicular lines, like this. You can see this curve is tangent to the first perpendicular line, second perpendicular line, third, fourth, fifth, sixth, up to this last one. The curve has to touch and it has to be tangent to all these perpendicular lines. So this is nothing but your cam profile. Okay, so this is nothing but the final cam profile. So if any doubt you can ask, otherwise I'll close this meeting. Okay, thank you.